All right, we're going to get started. So this quote came from a user. I was working on a large enterprise system, and I created a feedback service, a microservice. At the time, it was built with Java and Spring Boot with some of the Netflix stack, Zool, Eureka, and the like. So what bothered me about this feedback was, something I thought I understood the problem, and I created the feature, but I got this feedback, went to me, and what we did was analyze all the feedback, and a user said, hey, it's a good feature but flawed. And I started thinking about all the feedbacks we were getting for this large enterprise application. We're building apps for real users, and I think a lot of the times we forget that we're building software not for ourselves, but for other users, other humans. So another feedback we got was something like this. I have trouble seeing the labels. Sometimes we forget about things like accessibility. And having that feedback available for users to submit and actually get a response from the development team is really important, especially when it's their job to use your software every day for 8 hours at a time. So we have a lot of responsibility when we build our software. So this feedback service handled thousands of users. It was an enterprise app, and at its peak, we got 500 plus feedbacks a week. So the workers worked on shifts, and we only had a small team to triage, maybe 3 or 4 people at a time. So imagine kind of looking and inspecting each feedback. Is this a bug? Is this a feature? Is it just kudos? People are saying, hey, great job. And we're rolling out to a major deployment, retiring an old enterprise system. So feedbacks were really important to us. So how do we kind of scale? Because this is one application. We need to go across the enterprise with maybe 270 applications. How do we get that to scale? How do we kind of automate some of this? So that's what I'm going to talk about today. I'm David Hodge. I'm an independent software developer. I help folks with UX, Agile, and DevOps. My background is in Agile, specifically extreme programming. And lately, I've been getting more into UX and understanding user empathy. So in short, I try to help teams and organizations deliver quality software more often. So a quick aside of what I mean by enterprise apps. So what I think about when I say enterprise apps are apps that you have to use. You have no choice. Think about a business trip. When you come back, you have to do the expense software that you don't like to use, or that timesheet software that is a pain. What if you had to use that software all day, like for 8 hours? It'd be kind of a pain. And sometimes it's kind of lost on why we're doing this, or we don't really think about the user. And when I think about user empathy, I think about Steven Universe. If you don't know, he's half human, half gem, and one of his superpowers is healing. He cares about his friends, and likewise, we should care about our users. So one of the goals we had for collecting feedback was our users should be heard. It's feedback. It seems like a pretty straightforward thing. You just a little submit form, they put something in there, and then you collect it. But we have to be responsive. We have to get back to them in a given time if it's a serious problem. These feedbacks could alert us for serious issues. So I've been using Google Cloud Platform for probably close to a decade. And there's a buzzword right now, serverless. You'll hear about it. And I realized I've been using App Engine for a while. I don't know how many people are familiar with App Engine. It's by show of hands if you've ever used it. So I've been doing serverless before it was kind of coined, so you can update your resume if you've been using App Engine, and you can put serverless there. So they also have this, the way I conceptualize it, and I stole this from somewhere, is Cloud Functions, you're running one thing. You're doing just one thing. App Engine is you're running many things. It might be a web application or something like that. And Cloud Run, which is pretty new, is you can run anything. You have containers. So again, kind of a comparison, you can use App Engines for, I call it minimal ops. There's not much you have to do. You can kind of deliver whole applications by yourself if you're a full stack developer. It's pretty straightforward. And I've done this myself. I realized when I delivered kind of a full stack solution, I could use some help on the design side, but you can do it without too much ops. Cloud Functions are simple APIs, and we'll dig into the details. I'll kind of show you an example soon. One concept I liked, and I don't see this that often on other platforms, is these things scale to 0. So you understand kind of scaling up. As you get demand, you can scale up. Scaling to 0 is kind of like the lights. If we turn off the lights in your house, you're not paying for it. So it scales down where you don't have anything to do. And when I think of Cloud Functions, I think of one thing. So I think of a simple thing, you're doing it many, many times. And this, for whatever reason, gets stuck in my head. It's a simple punch. Martial arts is called a straight blast in Jeet Kune Do. It's just one simple punch, but if you do it multiple times, it can be effective. So Cloud Functions, they're simple, event-driven, not much ops. There's still some ops. You have to pay attention to some things. You pay for what you use, and I have a thing called ergonomics. Like, I'll show you an example, and there's not much you realize that makes it a Cloud Function. You're just building a Go function or a Node.js function. And again, you're just doing one thing. A lot of times when you build microservices or any feature, you hear the term feature envy, where you do one thing and then you start adding other things to it, and then you kind of have this kind of ball of mud architecture. So I'm going to show user feedback implementation, Cloud Functions with Firestore, and we're going to use CI/CD Cloud Build, and I'll kind of dive into that. One of the reasons I like Google Cloud Firestore is pretty simple, flexible. They have a concept of documents and collections, and I'll go into that right now. There we go. Okay, so I tried to come up with a good example of sending feedback to real feedback using Cloud Function. And a couple years ago, my son kept asking me the same question: can I ride this ride? And just would go down the list of Disney World rides. And finally, I decided to build a simple website with the Firebase just to show him. It's not a good website. There's a lot of problems with it, but I thought that would be a good example to kind of use to send feedback. So right now, this behind the scenes, I'm sending feedback using Cloud Functions. So I can do something like, please add SeaWorld, right? And this will go to Firebase using the Cloud Function. All right, and we'll look at the Cloud Function. Hopefully, you guys can see that. Is that too big, or not big enough, or is that good? People in the back? Zoom in a little bit. Good? More? There we go. There's not many lines of code in here. So this Cloud Function implementation is using Node.js, specifically Node 10, which is in beta. You can live life on the edge and try it in production if you want. But you can also use Go, and Java is in alpha. So all it's doing is defining a function, we call it feedback, and handling the request and response. So it's a REST endpoint using an HTTP trigger. And for each method, we really only care about posts, but for each method, you really should define something, because if you don't define an action or a response for a method, you will hang. It'll kind of time out, and you can just do something simple like 405, method not implemented. So the first thing you see here, we need to save this data. So we're using Firestore, and we're calling our collection in Firestore feedback, or feedbacks. And all we're doing is taking the request and looking if they have app ID, user, and the actual feedback, and storing that in the Firestore collection. And then we have a little log statement here to show what the feedback doc is, and sending it 200. So it's pretty straightforward. Not too much going on there. Again, you only want to do one thing. What helped me kind of iterate quicker was the cloud build. So you probably have used Jenkins in here, or you use more modern things like GitLab has a CI using YAML or Circle CI. So you can specify a trigger, which in Google Cloud, there's a cloud build CI/CD tool that you can define your YAML and your steps. For us, it's going to be NPM, and how to deploy, what arguments you need to deploy. And to deploy, we're simply just defining the functions deploy, the name of the function. I included an environment YAML just to be an example. What type it is, it's a trigger HTTP, the runtime, this could be Java, this could be whatever the supported ones are, and the entry point, which is the function name. And then I typically use the region, US East 1. And so anytime I commit to master, Google Cloud Build will pick this up. This code is on GitHub currently. Some other parts, you can see just by this directory structure, there's not much in this Google Cloud Function. That's kind of the point. I have a couple scripts. Tests don't really do anything. Again, this is an example. But you can put all your different scripts there, and we only have really one dependency. I was going to show the environment. You could have environment parameters. You could have things like your staging environment. You wouldn't put your secrets in here. Maybe I'll show you a different way to do that. So this is pretty straightforward. It's not very interesting code. So you can see that. So Google Cloud Function, this is the one that we just created. So I want to walk through that. So you can see kind of, okay, some invocations of the function. You can see that, I'll make it a little bigger. You can see the last time I deployed it, the region. You have to be aware of these parameters like the timeout, the last error I received here. And you can see the environment variables that I defined. So that seemed to work okay. Here's the trigger, and it's just a URL. So you get a URL, and you can use it and post to it. Kind of interesting, I thought, was that it uploads your code, and you can see the source, and you can even edit it, which is, you probably wouldn't do this for production, but you could edit it. And then for testing, you can test live here, and see if your function works. So we got an error because we have an empty JSON. So if we added something like valid JSON, sample That's an app ID. And then we had a feedback, test, feedback, right? So you can see we get back from Firestore, and I'll jump into that in a second, the document. And here's the feedback ID. And then at the bottom, hopefully you can see it's pulling back the log entries. So pretty simple, nothing that interesting about the Cloud Functions. Again, it's doing one simple thing. So we're kind of in the collection phase, and you can see the log statements. You can see what log statement we had. We kind of spit out the feedback. You can see when it started. It finished with this 200. So this is kind of the anatomy of a function. So if you were creating a function, you could see there's other parameters you have to consider, like memory, the type. And I mentioned HTTP, but you could have things where you are doing it based on pub sub, something getting inserted into Firestore, and the like. And here again, you pick your environment, Node, Python, etc. And you can even create it here live if you wanted to. And again, with the region and the timeout, you need to be aware of. And then environment variables, you could add them here, like a secret, if you wanted to. OK, so I mentioned we have these functions. We have this one function, and it's pretty vanilla function. It's just doing a post, and it's doing it to Firestore. I chose this because it's pretty flexible. I realized at the time we were kind of deploying to production like quickly, and I kept having to add different things, like, oh, we should really collect the browser information. We want to know if people are using IE6, like IE, the user information, maybe the user ID, maybe the roles of the user, and you can kind of iterate here, and while you keep collecting the documents, the feedbacks. And so I'm going to look at a couple of feedbacks from that roller coaster app. So you get comments, and these are all my comments. I didn't trust my friends to kind of help me out with this. Please include links to the park website. So you got all these comments, and if you had, context is everything. If you had a public-facing site versus an enterprise site, you might expect something weird, like a public site. You might have garbage like this. You have to, and you don't want to look at that. You want to kind of classify that as junk. We don't need that stuff. We don't want to waste time on it. So this gives you a feel of what the data would look like. And I mentioned the cloud build. So anytime I check into master, it runs, and it gets it from GitHub. Had many errors. I'll jump into that just to show you one example. So it's running the steps, the same steps as cloud build YAML. It's each step saying install, with the logs, and the failure, it failed on the deploy. Reason why it deployed or didn't deploy correctly is because, hopefully you can see that, there was an issue with the service account. So you can fix that and correctly have the permissions you need on the service account. So this is, if it's your first time in Google Cloud, it can be a lot to take in, but this is kind of all the moving pieces that you need to be aware of when dealing with Google Cloud functions. So that, I think, is the first part of this. We need to collect the data. Then you might have, you have to figure out how you're going to intake that data and classify it. So let's do this. Here we go. So hopefully that's a pretty good overview, just a lightweight overview of Google Cloud Functions. You kind of saw it on a live site, a toy website with roller coasters, and a walkthrough of using Google Cloud Build, the functions, and the basic anatomy of a cloud function. So you may not be kind of that impressed with that. It's like, well, I could I know how to write Google Cloud Functions. But what impresses me about Google Cloud Functions, there's no kind of hooks you have to call in other external libraries. I didn't have to say import Google Cloud Function, whatever widgets. I just had to write a JavaScript function, a node function. And that was pretty cool, because I just want to ship code, ship features. So one of the things I was mentioning is we had 500 plus feedbacks. And we kind of sat around as a team saying, OK, this is definitely a bug. And there's nuance in English language or any language, trying to determine what's a bug, what is a issue with user roles, and so on. And each application could be different. Each kind of, your context is going to be different based on what you're doing. So in general, we're trying to classify it, and we have to do that manually. But then we're going to jump into auto machine learning from Google Cloud and train, evaluate, predict. And it's not like a straightforward path. You're going to be iterating as you kind of see the prediction model. So first thing you have to do is get the data. So we're going to export our Firebase data to cloud storage. We need to get it on the available for AutoML, so we can create our data sets and do the training. So this is just a command. I think in terms of using scripts, because eventually I would want to automate this. You can do it with the UI and do the exports, but I kept forgetting all the steps. I'd rather have just a script that I can kind of put together and automate. So this script is the first line, and the output is saying, or the script is saying, export, use Firebase, export to Google Storage, and use this collection, our feedbacks collection. And that can take a while depending on your data, of course. So we have to import that data into BigQuery. BigQuery is like any relational database. You can write SQL against it. And here's the command for BigQuery. And we'll jump into that kind of shortly. And you specify the data set and the table. You can take data sets and create more tables as you need. And again, when I talk about classification, each of your use cases could be different. You're going to determine what makes sense. And 3 months from now, you might have a totally different new classification, and that's what happened to us. We kind of started out with, OK, these are bugs, and then these are features. And then 3 months later, we had to subdivide the features into planned features versus new features versus issues with roles. So one thing to remember, if you can't classify your own feedback that you're collecting, machine learning can't do it either. So again, context is everything. And when you're doing anything with machine learning, and feeding data for predictions, you should be aware of your biases, because it can affect people. Think about accessibility, and think about is there bias, and you kind of iterate and examine what you're doing, what you're inputting. So in general, what I did was take that CSV from BigQuery, and the column on the left is all the feedbacks. So you can have thousands of feedbacks. The line on the right, and this is all manual, you would classify. You would say, hey, this is kudos, this is a feature, NA, this is not applicable, and go down and split it up amongst your team or however you want to do it. And again, you're thinking about this in the long term. You want to kind of get to the point where you can predict a good enough amount of these. So it's going to be an iterative cycle. And then we would be training. We send the model to AutoML for training. You create a new data set, which I'll show shortly. And then if you need to tweak it, you iterate and say, you might find new labels. You might decide that what you're doing is incorrect in your assumptions, and then you have to take the predictions it spits out and evaluate. So you have to find out if the predictions are correct. When you get to AutoML, and you might find the precision versus recall percentages are high or low, where it's giving you false positives or false negatives. Think about your spam folder. Sometimes, whoever you're buying stuff from might say, hey, please check your spam folder, because the email algorithm for spam, falsely identified something as spam when it really shouldn't have. And again, this is the same kind of true positives versus false positives, false negatives. And then lastly, you're predicting. You're going to get the predict API in AutoML. You're going to say, OK, for this feedback, what do you think? And it's going to give you a prediction. And it's going to give you a confusion matrix, which you'll see. And it'll say, how confident is it in the prediction? And with that, we will take a look at AutoML. Little trick here. There we go. OK, so I was mentioning that we use BigQuery. So I took the CSV, and I got it into BigQuery with the command, right? So I created this table, feedback can rewrite. And it's just SQL. I can run it. I can see the data. Let's move this up. I can see all the columns if I wanted to, and you can see all the different feedbacks. And what I would do here is save the results as an CSV. So on the AutoML side, you get this dashboard, and all this stuff is beta on the AutoML. I'm doing text classification. There's sentiment analysis and entity extraction, but I'm focusing really on AutoML. So you would create your new data set here, new data set, decide which kind of classification you're doing. So in this case, it's single label classification, and then where you're getting it from. We got it from a CSV. So here is our model that we uploaded. We went and trained it. You can tweak things in here if you wanted to. It's like, oh, these are blank. Maybe I should say these are features. Or maybe these aren't labeled correctly. This is not a production example. Obviously, you need way more data than this. And they'll kind of tell you that you need X amount of labels. So you can see, like, you need at least 100. And you probably need more than that to get some good predictions. So keep that in mind. This is just showing you the example. And I'll jump into one that has thousands, like around 20,000 examples. So then you go to training. And because I have, this is not a real example, I don't have that much data. The precision recall seems to be 100. And we'll test a prediction. You'll see the score threshold, which you can change for the precision and recall, whether it's a false positive or a false negative. And I'll show a better confusion matrix with another example. But it's basically saying it's 100% confident it knows it. It knows what this feature label is. And so we can test that out right now. So I can say, just some garbage here, and see if it predicts it correctly. So it said NA. I can do something like, we need more rides in the database, or something like that, and see what it says. Feature. OK. So you can see down here, it also gives you a handle on the REST API. So if you think about it, you can get the whole cycle. You can take this REST API, and you could do things like, once a feedback comes in, once you get advanced enough, get enough data, you can run this as another function to insert a prediction. that prediction may or may not be right based on your kind of model, but something you could do. So I want to show you a real or a better example. So here's an example of the tutorial in AutoML I encourage you to take a look at. So this has 12,000 texts, happiness, things to do with happiness. So you have achievement, affection, bonding, enjoy the moment, exercise, leisure, nature. So the training model or the training for this will look a little different, more realistic, right? So it's about 87% with precision and 84% with recall. So here's what a better or more realistic confusion matrix would look like. So for achievement, for the true label that humans kind of said, this is an achievement, it's about 80% accurate in saying, yes, this is achievement. Sometimes it might say that it is enjoy the moment. But running down the line here matches up with what humans think. So its weakest, it seems to be with enjoy the moment, which is kind of a nuanced phrase in itself. So you can kind of see the kind of, it's not going to be a straightforward algorithm where you say, this is how we get 100% predictions. So I'll use this, and I've used this earlier, and it seemed to work pretty well. So I'll do a prediction. I'll say it's the end of the school year, so I'll say my kids got great grades this year. So I'm not sure what label it will give me. Let's see how it does. Affection, about 68% likelihood it could be affection. Could be. I think that works. Another one you could do, I have 2 soccer games this weekend. See if it thinks that's exercise. So leisure, it's not that leisure. I don't think, not my soccer games, but I would think that's exercise. So it's not going to be perfect. So the point is, you're not going to, do this one time and say, oh, it's 100%. We can predict everything. You're going to have to kind of iterate through this and kind of go through it a couple times. Yes?
Did you say that you could use a function call network state API?
Yeah, so you could implement, so exactly. Now what would you do that you kind of have this whole full cycle? You have the data, you have your training, and you think it's maybe 80% or whatever you get it to. You could create a cloud function using the predict API. It gives you that handle on it. And you could say, if you wanted to, insert another column saying, I predict this to be garbage, or I think this is a new feature, or this is a user role issue, or whatever your context is. But you're going to have to iterate every 3 months, 6 months, or whatever it is, based on how much data you get and how good your data is. If you have something on the a roller coaster ride with kids entering stuff, it's going to be a lot different than enterprise apps where people have to do serious work. So one thing I would do, I showed you a bunch of commands. I would just learn those commands, get some scripts, automate it, so you can take data out of Firestore or wherever, and put them into the training, AutoML. You might want to do things like, if something's serious enough, you have something critical, it could signify, hey, maybe your app is about to crash. You can automate actions. If we get some kind of feedbacks like this, we might want to say, oh, whenever we get these, like 5 of these things that say, hey, app's running slow, let's just fire alerts. Let's wake up some people, potentially. So what is the point of all this? Why do we do this? Why do we care? Like, feedback is a pretty vanilla thing to do. We want to, limit the human resources. Like I said, not every team has the luxury of having 5 dedicated developers or analysts to look at every piece of feedback and get back to the user within like a week. So we're looking at ways to scale. But most importantly, we're trying to help our users. We're trying to say, hey, we know you have to use our application. We want to give you the best experience, and we want to be responsive. Because nothing worse than firing a feedback into some site and you don't hear anything for months, or it just takes too long and you've kind of moved on. So that can be important. So this always comes to mind. I mean, if you ever seen Indiana Jones: Lost Ark, Raiders of the Lost Ark, it's not a exact science. It kind of puts something you think will work, and it may not. So it's not exact science. You kind of iterate, iterate, iterate. And in general, I mentioned serverless, but I'm looking forward to playing more with cloud functions and specifically Cloud Run. I've been playing a lot with Closure, so I want to see how I can use Closure on Google Cloud Run. It seems pretty interesting. And then one last thing, I help out with DevFestDC, so if you guys are interested, well, you should be interested in DevOps in general. It's July 8th and 9th in DC. I'm going to post the slides at some point. These are some resources, and I'm free to talk in person or on Twitter. Here, I'll leave this up for a while. But hopefully you learned something more than the technology, but just thinking about users and having user empathy. Thanks.
Mm-hmm.